This is what a quarter wave 20 meter 17-foot telescoping carbon fiber antenna looks like here in my backyard. And to the left, about 30 feet, is a stainless quarter wave 20 meter antenna. Hey everyone, I'm Bob, KD4 BMG HOA Ham, and yes, you did hear me, I did say carbon fiber. And when Gabil Radio first said to me, Bob, we're going to make a carbon fiber antenna, I did say you can't do that. Now, they specifically started with developing a carbon fiber antenna that would be a complement to their 7350T or TC coil antenna. And it was to replace this rather lightweight and delicate stainless whip. Now, this can also replace a Manpack collapsible, but this is not a replacement for a quarter wave 20. I didn't realize while they were making this that they were also making a quarter wave 20 version of it. And when I introduced these carbon fiber antennas a couple of weeks ago on my channel, I told you I would be doing a very specific video on that quarter wave 20, and that's what we're going to do now. I do have an update from Gabil Radio. This is now rated at 400 watt single sideband voice, 300 watt CW, and 200 watts FT8 or digital mode. So those of you who like to go at it with digital modes, have at it with your 100 watt transceiver. This antenna couldn't care less. It can handle it. So 400 single sideband, 300 CW, 200 digital. What are we going to do with it? Well, we're going to continue making great steaks out of the sacred cows and breaking paradigms, even if they're only my paradigms. Since I introduced this, some of you said to me, Bob, people have been doing similar things in Japan for some period of time. And I've investigated that a little bit. People have taken carbon fiber fishing poles and converted them into multi-banded, or I should say broad-banded antennas with matching units and such. Well, this is the first ever designed quarter wave 20 with telescoping sections specifically for 20 meters. But we want to do a whole lot more than 20 meters. So today what we're going to do is we're going to hook it up to an M coil, which will get it resonant on 40 meters. Will that work? We're going to hook it up to a 5-to-1 matching unit to give us a broad-banded antenna from 6 to 40. Will that work? We're going to compare it to another quarter wave 20, this stainless antenna from Intellitron. That will suffice if I put any other 17-foot quarter wave 20. It really doesn't matter the brand. They're stainless versus carbon fiber. Do they match up? And when I do this comparison between these two, they're both going to have everything else exactly the same. It's going to go on the same blank adapter, the same puck for radials, the same length wire radials, 3 at 16.5 foot each, 2 of the same ground spikes, 2 sections of 75 feet long coax. And then we're going to look at whisper comparisons between these two. We're going to get a look at whisper on the 5-to-1, and then we'll make some contacts with this coil that gets us on 40 meters. We'll do some SWR, as much testing as possible to show you that that quarter wave 20 carbon fiber mast, carbon fiber antenna is just as good, if not better, than stainless. It costs more. It costs more money to manufacture those carbon fiber sections. The material is more costly. We have to get some benefit out of that extra expense. We'll talk about some of those benefits. Let's get to it. One of the obvious advantages of going with carbon fiber will be weight. Let's compare this to some other popular, readily available, well, almost, that's the MFJ 1979. Can't get that anymore, so I have a piece of history. This is the BD7 IBI. You can get this on AliExpress. It's the cheapest whip out there that I can think of. It also is the least quality, but I keep these around for destructive testing. And if I do something that I think is going to destroy an antenna, I use one of these cheap ones rather than one of my good ones. We come in at 9.15 ounces. The next would be the Intellitron from Gigaparts. This most closely represents most of the whips that are out there today here in the USA. Oh, 3/8 by 24 versus M1015. And here we are at 14 ounces. Let's get a look at the MFJ 1979, not deployed in the field. I bought it a couple of months ago because I consider it a piece of history. It's also the longest of all of these. It's about 1.5 inches longer than the carbon fiber 5200. It's longer than these as well, the Intellitron, and about 6 or 7 inches longer than the BD7 IBI. Look at that. It's no heavier than the Intellitron version. And now for the carbon fiber, and this is weighted low to this side because of this metal adapter. I'm leaving the adapter here to go M10 1 to 3/8 by 24 because this is how I would deploy it. 8.7 ounces. That's exactly what we would have expected to see, a much lighter weight for the carbon fiber antenna. So only 1 ounce difference between the carbon fiber and the BD7 IBI, which I consider an inferior quality antenna. Doesn't mean it doesn't work for you, doesn't mean it doesn't put out RF, but the construction is inferior to the Intellitron, inferior to the MFJ 1979, the Chameleon SS17. The carbon fiber is what, about 6 ounces lighter than those. We do need to talk about this carbon fiber as we start doing some of our testing, because in my initial video I told you it's an all or nothing. When you extend the sections of these carbon fiber whips, you must extend them all to get continuity. You heard me slip earlier and refer to this as a carbon fiber mast. Well, that's because it's kind of the friction fit here. It's a pull and twist, and when you break it down, you do the same thing. You twist and retract. So it's an all or nothing antenna. So then that begins to make you question, well, for this quarter wave 20, then how do I get resonant on some of the other bands? Well, with our matching unit, we'll be able to get on some of the higher bands. We'll be in a good SWR position, and then we could tune up, or we could just operate based on the SWR, or we start adding this CF5200, the 17-foot whip, onto a coil, and then we lengthen it, so to speak. I know, true, it's not lengthening, it's adding some capacitance to that antenna, but then we're going to be more along the lines of, say, a 5/8 or a half wave, or maybe even a full wave. And I'm not actually showing that testing in this round. That's something I'm going to do in a future video. Turn this into a half wave on 17 meters, or a 3/4 wave. I've never done anything like that, but it's something that I do want to investigate and share how we go about doing that. So you get your 20 meters, which I operate on all the time. You put it with a matching unit, you get a broadbanded antenna. You put it with a loaded coil and you get it on 40 meters, or you put it with a coil like this, which is adjustable, and then you can take this quarter wave 20 and start getting half wave, 3/4 wave, 5/8 wave, full wave on 6, 10, 12, 15, 17. All right, so on to some of the next tests.
Thanks very much, 7-3, take care. Whiskey 9, India Sierra Fox, secures it.
Kilo Delta 4 Bravo Mike Golf.
Kilo Delta 4 Bravo Mike Golf. Thanks very much. I've got you a 5-9 into Central Indiana. Name is Ken, Kilo Echo November. Go ahead.
Hey Ken, the name here is Bob Bravo Oscar Bravo in Tampa Bay, Florida. You're also a 5-9 here in Tampa Bay this evening. Over.
Yeah, very good. Well, good deal, Bob. Good to work you again. Looks like we worked you last year here on 40, so good to get you in the log again. Be sure to check out our CRZ page. You can see this year's QSL card and how to pick it up if you'd like. So all the best. Take care. Have a good rest of the weekend, and have a good one ahead. From Whiskey 9 India Sierra Fox, 7-3.
7-3, friend.
All right, thanks. So Whiskey 9 India Sierra Fox, special event station for the Indiana State Fair. Only this year in Santa Monica.
I used the Chameleon end coil to load this 17-foot whip up for 40 meters. I didn't play with my radials at all, as I had them set up for 20 meters, and you can see that SWR is in a pretty good spot for operating single sideband voice. I did touch it up just a bit for my FT8, and you can see that I was able to make contacts at will. I run PSK Reporter for 15 minutes, and you can see I am absolutely getting out. And yes, I ran FT8 at 100 watts. So knocking off my paradigms one by one, confirmed that using a loading coil lets you take this quarter wave 20 and work it on 40 meters. And if you have jumper holes in your loading coil, then you can quickly take that setup and just go from 20 to 40 at will. So what happens when we put a 5-to-1 matching unit on or with this whip? Let's get a look at that next. Before we get to the 5-to-1, let's talk about the thread sizes on this. I covered it in the initial introduction video. At that point, I was focused on the 2200, and it's the same for either one of these versions. These come with M10 threads on the bottom side of the antenna. So this will match up to all the Gabil radio products. Their 7350 TNTC, their RPG, and their new 330 powered screwdriver antenna. It comes with a M10 1 to 3/8 by 24 adapter, so we can use this with all of our gear here in the US. But what do you do if you're one of those people that prefers some of the lesser quality and lower cost items that you can pick up in Asia on AliExpress? Well, first of all, make sure you do determine which of these sides is the positive and which is the ground, because you got a bargain, but they didn't mark that for you, so you could be sending your signal into the ground. That said, if this is how you want to roll and you want to get an M10-15 ground spike on one side and you want to get this coil on the other, which I assume is a 40-meter coil, I haven't tested that yet, you will need another adapter that will go M10-15 to 3/8 by 24, and now you're golden to go with either the 2200 or the 5200. If you're going to use this coil, well, go over to the 5200, then this will get you on 40 meters. So that's adapters, and that's how you would convert it for this lower cost, a little bit lesser quality gear that comes out of Asia. Maybe that's how you want to roll, and that's perfectly fine. Use your matching unit of choice to get broadbanded with a 17-foot whip. Mine is the CHA Hybrid Micro or Mini, because the matching unit itself becomes the base and the attachment location for the vertical whip, and I find that incredibly versatile and quick to deploy, and it gets me an acceptable SWR. Whisper results on 10 were acceptable given the time of day and the band conditions. 12 was looking very respectable, along with 15 meters. I chose to use Whisper just to confirm the correct operation of the micro with this whip. 17 top left, 20 top right, 30 bottom left, 40 bottom right. I want to get through this because I don't want to lose you before we get to what I believe would be the most convincing part of this discussion, and that's really comparing this with a 17-foot stainless whip, because that really is a like-for-like comparison. But before we do that, let's talk more about some of the benefits beyond just the weight difference of this compared to a stainless whip. We all know that carbon fiber is a very strong material, and while this is new to market and we don't have enough history to really know, we would expect there to be a great deal of durability associated with this type of antenna. I only have one of the 5200 and one of the 2200. When I get my hands on a couple of more of these, once they become more readily available, I will do some torture tests on them, but intuitively we know that carbon fiber is very strong. So I expect durability out of this. You're part of the process of figuring this out as you use it. I do want to show you one more thing about the lightweight. I don't ever take my whips and put them on the MK3 tripod and just let them stand up out in the air without any weight on the legs of the tripod. But I did that with the CF5200 because it is so light as you go up to the tip of this antenna. And even though the MK3 tripod is very lightweight, this thing can stand up to some wind. I had storms coming through the backyard here in the HOA, and I just set this up and wanted to see if it would stay upright without any weight on the legs. Don't do this. Meaning, if you're going to set this up on a tripod, at least put some weights on the legs. It will stay upright if you do that. Because this is so heavy to the bottom side of this antenna, you have a very low center of gravity, and it shouldn't take much weight to keep this thing upright on a small tripod. So I really hope you've stuck around to this point, because for me, this is the most exciting part of this video. We're getting to whisper comparisons of two almost exact antennas, quarter wave 20. They are resonant on 20 meters, but they could be any different. One stainless, one carbon fiber. I've broken all of my paradigms. The paradigm being you can't use carbon fiber for an antenna because it won't work. Well, I had that paradigm because of all the times we talk about make sure when you hang a wire antenna, it doesn't touch your carbon fiber mast because it will ruin your signal. Well, I just automatically assumed carbon fiber wasn't acceptable for transmitting RF. Gabil Radio has figured out a way to do it. They have a secret sauce, a special recipe with their manufacturer, and it works. Much of what I've done has shown that it's comparable to stainless. This shorter one is a great replacement for those small, fragile stainless whips, right? This is just a no-brainer to put this with a small coil or to replace the man-pack collapsible because it's going to be lower weight and cube. But what's this CF5200? What's the advantage of it? Well, I don't think we know all of the advantages yet beyond weight, potentially, durability. We just don't know what's going to happen as a result of this, because some of you are going to begin experimenting, doing things that we have never been able to try before. I think that's what excites me most about this. All right, let's go into the backyard and let's get this set up. Two exact same setups, and that's why this is the fairest comparison of all between these two quarter wave 20 vertical antennas. Same coax, 75 feet. Same ground spike, same base, the chameleon blank adapter, same radial puck, same radial wires. Everything is the same, with the exception of one is going to be a quarter wave 20 stainless steel vertical whip, and one is going to be a quarter wave 20 vertical carbon fiber whip. How will they perform?
You are set.
Kilo Delta 4 Bravo Mike Golf.
That's a Kilo Delta 4 Bravo Mike Golf, 59 New Jersey.
59 Tampa, Florida.
Thank you. You are set. Kilo 2 India.
That QSO was with the carbon fiber antenna. I spent a good bit of time using my SDR with SDR Uno, and that's what you saw behind me during that QSO. It lets me get a good look at the waterfall. It lets me watch signal strength, and I can't hear any difference. I can't see any difference between the carbon fiber and the stainless. Now, my eyes and my ears are not calibrated instruments, so it's anecdotal information, but it's imperceptible to my senses. The SWR reading on the stainless, I don't think any of us would be concerned about operating with this. 3 radial, 16.5 feet, the whip fully extended. SWR on the carbon fiber, the whip fully extended, 3 16.5 foot radials. Overlay the SWR one over the other, no perceptible difference between these two whips, carbon fiber to stainless. I spent time on FT8 with the carbon fiber 5200, 20 meters. I made contacts at will, and PSK reporter, just looking at 15 minutes of operating, you can see on the map I am absolutely hearing and being heard. This carbon fiber whip works. Those who watch the channel regularly, which should be all of you, you've watched me use Whisper previously, and you know I really like to do it when I'm comparing two antenna systems which are nearly identical with one variable. This is the perfect opportunity to do that. So I ran Whisper for about 12 hours through the night on 2 different nights. On day 1, I had each antenna set up to 2 different Whisper transmitters. For day 2, I swapped which antenna went to which Whisper transmitter. That way, if there are any anomalies or differences between the 2 Whisper transmitters, even though propagation might change from day to day, I've done everything I possibly could to spread any variability by switching the transmitters and the antennas between the 2 days. I've tried to get the best data possible. Let's look at the maps, and then we'll look at the statistics. Here's the Whisper map for the stainless whip day 1 and then day 2. Here is the Whisper map for the carbon fiber 20 meters day 1 and now day 2. Go ahead and stare as long as you need to. You're going to have to look for a little while before you do see some differences between the stainless and the carbon fiber Whisper maps. They are really insignificant from my perspective, but there are some very minor differences. We have to come on over here to the actual data set to see if they are comparable or if one has an advantage over another. So let's go ahead and look at the data. When you run Whisper, you not only can pull a map, but you can pull a set of statistics that give you a lot of data about the various stations that are picking you up. So that would be the reporter. This station is reporting what they heard from me, what the signal to noise ratio is. So we have a stainless day 1, a stainless day 2, a carbon fiber day 1, a carbon fiber day 2, and then I combined all of that information together, and then I add this into a pivot table. So I have pivot tables and charts. So we're going to compare the carbon fiber 5200 to the stainless Intellitron antenna. We're going to look at signal to noise ratio and the total number of contacts. 11,134 are the number of contacts that were made from the carbon fiber in those 2 days, and the count for the stainless is 10,811. Put that in a percentage, and it's 51 to 49 between the two. Virtually irrelevant. Who cares? Those two antennas, we would say at that point in time, are almost exactly alike. Is there anything else on here that shows a differentiator? Well, the number of contacts made counts the fact that a single station could have reported hearing me over and over and over. So that's how we get a total of 21,945 contacts. But unique stations, this would be how many unique stations heard me in that 24-hour period, or those 2 days, 12 hours each. For the carbon fiber antenna, 345 unique stations picked me up. On the stainless, 353 unique stations picked me up. So again, it's almost a wash. There's a slight edge over here in the number of contacts with carbon fiber, and a slight edge right here to the number of unique stations between the two. I'm going to say that so far we have a draw. Irrelevant differences. Is there anything in here that's a differentiator? Well, the signal to noise ratio in Whisper indicates whether or not you might be able to have a single sideband phone contact. And that's important to those of us who prefer that mode of operation. So that's what this is up here. This is the SNR, the signal to noise ratio. And in this case, the highest signal to noise ratio that was achieved was 11. The lowest was negative 34. And on the scale of SNR for Whisper, that is as low as you can go. These numbers right here represent the number of contacts that were made at the various SNR levels. It is known that a SNR level of 0 and higher for Whisper will likely result in a single sideband phone contact. So that means for the carbon fiber, I could have had 123 voice QSOs. It's also known that anything down to negative 10 could quite possibly achieve a single sideband phone contact. And in this case, I have 1,484. You start getting in negative 11 SNR down to negative 15. Some of those might result in contacts, some might not. It's getting a little bit more sketchy at that point. But notice this information here. On carbon fiber, I have 123 likely single sideband contacts, with stainless only 72. To me, this is pretty definitive, saying that, oddly enough, the carbon fiber seems to work better in giving me an SNR that's higher with a higher count. 123 versus 72. You get down to 11, or to the yellow section, you get 1,484 versus 1,241. Into the pinkish section, 1,883 versus 1,801. So in total, 3,490 contacts possible versus 3,114. Now we have something that's a little bit more substantive, especially when you're looking at that SNR 0 and higher. To me, that is a differentiator. Does this mean I'm throwing out my stainless whips? Absolutely not. I love all of my stainless whips. I have a pretty significant collection of them. But there seems to be an advantage to the carbon fiber when it came to SNR for whisper, and SNR 0 and up indicates the likelihood of a single sideband contact. So total number of contacts, unique stations, it was a wash. When it comes to the number of stations that had an SNR that is likely going to result in a single sideband voice contact, the carbon fiber whip seems to have an advantage. So my carbon fiber whip, it has a weight advantage. It's lighter. It might have a strength and durability advantage. I have yet to do any destructive testing because I only own one of these. I'm not going to test it to the point of destruction. I need to get my hands on a few more of these. When you look at the whisper from SNR 0 and up, it seems to have an advantage in making contacts. So, is a carbon fiber whip better than a stainless whip? I think the jury is still out on that, but what we certainly have is something that's making us scratch our heads and go, hadn't thought about that before, and now we have something to think about, play with, experiment with, and isn't that what ham radio and amateur radio is all about? I hope you would consider joining me in this experiment. I've turned the sacred cows into delicious steaks. I've broken my own paradigms and some of yours. I'm having a blast doing it, and it just feels like this is going to keep going on and on and on. I hope you stuck around with me to the end and saw this impactful data set that's leading us to a conclusion. I hope you enjoyed this. More to come, friend. Talk to you soon. 73.